For weeks, the scientific world has held its breath, waiting, watching, wondering, when China would finally release the data. While NASA, ESA, and every major Western observatory struggled with the blinding geometry of the Sun and the dust storms sweeping across Earth's atmosphere, one spacecraft had the perfect vantage point. One machine stood above the noise, above the uncertainty, orbiting Mars in silence, armed with instruments designed for clarity, not politics. That machine was Tianwen-1. Tonight, the silence has broken. China has released the first confirmed images of interstellar object 3I, Atlas, captured from Mars orbit during the period when every telescope on Earth was blinded by solar glare. These images, combined with Tianwen-1's ultraviolet and dust monitoring data, reveal a side of 3I Atlas we were never meant to see, a side that contradicts every prediction, defies every comet model, and amplifies the mystery surrounding the most unpredictable visitor our solar system has ever received. These images don't just fill a gap, they expose it. They show an object behaving in ways that are not only unexpected but impossible. And now, with China's release, the world must confront a terrifying truth. 3I Atlas may not be what we thought, and someone outside Earth saw it first. The story begins with a simple, yet crucial, detail: geometry. At the moment Earth-based observatories lost visibility of 3I Atlas, Tianwen-1 occupied a perfectly aligned orbital segment, giving it a clear, unobstructed line of sight across interplanetary space. No sunlight interference. No atmospheric scattering. No horizon obstruction. Just a silent, pristine viewpoint above the Martian sky. While NASA's telescopes were blinded and ESA's fleet suspended tracking, China's spacecraft continued monitoring without interruption. It observed 3I Atlas during the critical period before perihelion, the moment when comets reveal their true nature: fragmentation, tail morphology, energy output, and sublimation patterns. But what Tianwen-1 recorded wasn't expected. It wasn't chaotic fragmentation. It was structure. Stable, bright, accelerating. The first released frame shows a faint, slightly elongated point. Not dramatic at first glance. But scientists immediately recognized its significance. A massive dust coma, not thinning, not dispersing, but stabilizing, forming a symmetrical plume around the object. Every wavelength analysis confirmed it. A dense coma, a sunward-facing jet structure, a tail measurable from Mars orbit, and brightness far higher than anticipated. The real shock? The coma's brightness fluctuated periodically. Not random. Not chaotic. A pattern. Patterns in interstellar objects are never ignored. Tianwen-1's ultraviolet sensors recorded spikes in UV reflectivity corresponding to rotational models, but the amplitude was far too high for a small nucleus. Something was spinning faster or reacting in ways physics shouldn't allow. This was not a quiet comet. This was an engine of energy, and China had the only camera pointed at it. As Atlas approached the Sun, European ground stations went fully blind. Direct imaging was impossible. Earth was looking straight into sunlight. Any attempt to track the object would be drowned in glare. But orbiting Mars, Tianwen-1 remained the only unblinking eye. It captured the development of new jet structures in real time, the elongation of the dust tail, and the formation of the anticola, a plume stretching millions of kilometers. The anticola grew faster than any early models predicted. This wasn't simple outgassing. This was directed release, forming coherent lines instead of chaotic sprays. Yet fragmentation, a necessary consequence under classical comet models, was nowhere to be seen. Earth had lost control of the narrative. Mars had become the only witness. Photometry from Tianwen-1 showed something astronomers immediately recognized as impossible. A brightness increase of 0.3 magnitudes with no visible structural breakup during a phase when fragmentation should have occurred. The energy profile suggested a shattered comet, but the structural profile was intact. This is why Tianwen-1's images matter. They reveal the first true contradiction in cometary physics. An object cannot produce jets of this magnitude without exposing surface area that no single body of its size possesses, unless the object is hollow, layered, or not a comet at all. China hesitated before releasing these images because this is the kind of data that doesn't just generate controversy, it generates fear. Every instrument on board Tianwen-1 agreed. There is structure inside the coma. Not dust. Not noise. Not artifacts. Structure. A dark ridge runs through the light envelope, a region of suppressed reflectivity that shouldn't exist if the nucleus were spherical or irregular. It repeats across exposures, axially aligned with the jets, suggesting either density folds, thermal shadows, or geometric occlusion. One possibility, long avoided by traditional astronomers, is the most controversial of all: a structured nucleus. Tianwen-1 also captured the most unsettling phenomenon: a sudden brightening on the side opposite the Sun. Comets brighten toward the Sun. They eject material from heated surfaces. But Atlas did the opposite, reflecting or emitting energy from its cold side, as if something inside had activated or pulsed in response to solar input. China called this photometric inversion. Something was operating like an internal mechanism, not melting ice. Once these images were released, Western agencies scrambled to reconstruct the missing data gap. But the quiet resignation in the reports is palpable. Earth has lost its monopoly on astrometric truth. For decades, our planet was the observer, the authority. Now, a probe orbiting another world has taken the lead. The jets match no Western models. Brightness evolution alters orbital solutions. Lack of fragmentation contradicts acceleration readings. Dust-tail geometry is incompatible with a single coherent nucleus. The object must either be fragmented, hollow, or operating under unknown physics. No one writes this explicitly, but Tianwen-1 forced the truth. 3E Atlas is not behaving like a comet. It is behaving like something that adapts. The document concludes with a somber, almost philosophical reflection. We are observing an object older than our Sun with machines barely older than our grandparents. The first interplanetary mission of a rising space superpower has captured something that may rewrite the story of interstellar travel. We expected dust. We expected ice. We did not expect intention. Tianwen-1 gave us a glimpse of 3E Atlas from above the noise, from beyond the Sun, from another planet entirely. The images do not solve the mystery, they deepen it. For the first time, humanity's home planet was not the witness to its own cosmic history. A machine orbiting Mars saw it first. The most haunting part is not the brightening, the sunward jets, or the anticola. It's that Earth never saw any of it. For the first time, humanity was not the observer. 3E Atlas is shifting, pulsing, brightening on the wrong side, releasing jets in the wrong direction, forming structure where randomness should reign. It refuses to fragment when physics demands it, gathering energy where no comet can. It behaves not like a relic of chaos, but a relic of something organized, something built, something ancient. And now, the world waits. Not for another press release. Not for another theory. But for the next data drop, the next image, the next anomaly that will either deepen the mystery or finally reveal what 3E Atlas truly is. If these Mars images left you questioning what Tianwen-1 really captured, don't let that curiosity fade. Subscribe to the channel. Turn on notifications. The next observation could change everything we think we know about interstellar visitors. And tell us in the comments, is 3E Atlas a natural comet, or did Mars witness the first interstellar system ever seen by human eyes?